Okay. All right, we are adding on 7-5 today. It's actually just like an add-on of 7-4. So, here we go. Page 1. Okay, so we're adding on special segments of triangles. So there's 3 special segments we need to talk about. The first one is called a altitude. Not to get confused with attitude. Altitude. Okay, here's what an altitude is. It's when you have a triangle and there's a perpendicular line dropped to form a 90-degree angle. So in these 2 triangles, your altitudes are A, D, and F, J. Those are your 2 altitudes. The reason that's important is because these 2 triangles are similar, and because of their altitude, we can set up a proportion using the altitudes. So your proportion would be set up AD is to FJ as AB is to FG. Okay? Or you always use your altitude, but it doesn't matter which side you use. So you can have AD is to FJ as AB is to FG, or you can use the other sides, which would be AC to what? Or FH, whatever. Okay, so you're always going to use your altitude, but your sides can change. So that's using altitudes. Our next special segment is not anyone new. Welcome back, angle bisectors.
Is that the one between the circles?
This is just where you have a line and it cuts 2 angles in half. Okay, so you have a line and it cuts both of these angles in half. Because you have angle bisectors and 2 triangles that are similar, you can set up your proportion to say LP is to RT as LM is to RS. Now this can also work the other way. You always use your angle bisector, but instead of using LM to RS, you can use what? LK is to RQ. So this one can change. I feel like my voice is echoing today. But you always, let's just put a heart because we love our angle bisectors and we love our altitudes because it's February. Always use your altitudes and your angle bisectors, but your sides can change. Okay? All right, last special segment is called a median. Median. Your medians, oh, I didn't write our angle bisectors. Our angle bisectors in this case were RT and LP. Our medians in this case are DC and ZY. Those are your 2 medians. Okay, same thing. You set up your proportion using your medians. CD is to YZ. However, you would set your second one to be the whole thing. AB is to WX. So you can use, this is the whole length. But here's the deal. Isn't AD the same as DB? Okay, so if you're going to use this median and you're going to say CD is to YZ, you can also set those proportion to just half. So if you said CD is to YZ, you can say AD is to WZ because it's cut in half. So it's proportional. Does that make sense? A little bit? This is a lot of information up front, and then we just have to put it to good use. Okay? So if you turn the page, I know that this is an example and that the answers are right here, but it's better for your brain if you write it. So let's do this one together. We have angle bisectors. AP is an angle bisector, and QF is an angle bisector. Solve for X. Well, we're going to set our angle bisectors together, so we'd have X is to 8. Now go back to the triangle we started with and use the side to the other side. So 15 is to 12. You would cross multiply. And you'd get X is equal to 10. It's all about setting up proportions. Okay? Alright guys, I want you to try 1 and 2. Check your answers. So it's just setting up proportions and using different parts. What did we use in number 1? What was our special segment? Yeah, but what's it called? What's that thing? What's it called? Like, I know that's the segment. What's it called? Altitude. Altitude, and this one was median. Yep. You either had altitude, median, or angle bisector. Okay? There's one more theorem to tell you about, and it's using angle bisector. Okay, so it's using angle bisector. So here's the deal. We used angle bisector right here. But how many triangles were there? 2. There's 2 triangles, 2 separate ones. Okay? Well, in some scenarios, you're only going to have 1 triangle. So, this theorem, the triangle angle bisector theorem, tells us that if you have an angle bisector, this is the same as this, then instead of using JM, your angle bisector, to set up the proportion, you would set this side is to this side as this one is to this. And it's written right here. You would say KM is to LM as KJ is to LJ. So you use this when you only have 1 triangle, but it's split by an angle bisector. Does that make sense? Let's put it to use. Let's try it. Okay, so flip the page. So in example number 3, we only have 1 triangle. So we're going to use the triangle angle bisector theorem. So instead of setting our angle bisector proportional to anything, we're going to set the side. Which side do you want to start with?
6.
Oh, okay. 6 is to 14 as, so I use this part, 6 is to 14 as X is to, are we sure? Huh? Yep, 18 minus X. You're going to use that a lot when you know the whole and you know this, but you need to know this portion. So the whole thing was 18. This baby piece is X. So this has to be 18 minus X. So it would go right here. Hey, we all open the door, please. For what?
For the test that we're taking.
I didn't catch your Kansas class. Okay, bring it back. It's right there. How about it? How was it? Is that what y'all got? Okay, what I want you to do now is I want you to try 3 and 4, and then we'll go over it. 3 and 4.
Aren't testing on
No, not even graded. They'll be graded so we can go over them on Wednesday. Do I get that? Do I need to show how I got it? Okay. All right. Now I want you to try 5, 6, 7, 8, 9, 10. But some of these numbers are very, very light. So I want to go over, like on number 7, this is actually an eyeball. And this is the pupil. Does that make sense? Okay, so you need to know that. And then number 8, this is 10, 15, 4, X, 15, Z. This whole thing is 32. And then this is 9. And then this is 17, 15, 7.5, and X. So I want you to take this time and go all the way 5 through 10.